I got 46 seconds, and it was moving fast.
So you got, which one was it? 6?
46, yeah.
And what was the time for 3%?
Observation was moving fast.
155 seconds.
Is it 55 or 155?
155.
155, okay. So are we starting to pick up on any trends that are happening here?
Yeah, the more concentration, the faster it goes.
The more concentration, the faster the reaction happens?
Mm-hmm.
Cool, okay. So what do we see? Do we notice any trends that are already in the concentration?
Yeah, like the stronger it is, the quicker the balloon filled up.
So the more concentration, the quicker
Yeah.
the balloon filled up. And then what about the temperature? Does anything feel kind of off right here?
Yeah, it's kind of weird how like the hot, well, I mean the room temperature is 180 seconds, and the cold is 158 in the hot.
Do we feel like that this isn't following a trend?
Yeah, because I feel like it should be like lower.
So plot the data as you see it, then make sure to mention that. Okay, thank you. And then do we notice a trend for concentration overall?
The lower the concentration, the longer it takes to rise.
The lower the concentration, the longer it takes to rise. Okay, awesome. And we see that throughout data here.
Yeah.
And then what about temperature? Does anything seem off about the temperature?
The higher the temperature, the quicker it rises.
So we think the trend is the more temperature there is, the higher it is, the quicker the balloon's going to rise.
Yeah.
Okay, cool. Let's get that data plotted.
Okay.
Do your best to work together on plotting that data. As soon as you have your data plots, you are welcome to move into the conclusion section at the bottom there as well. What did we see in our concentration? Do we have any trends that we can identify already?
The higher the concentration, the faster it,
The faster the balloon fills?
Yeah.
So we see as concentration is increasing, the balloon is filling faster. So what's happening to the time?
is decreasing.
Okay, so what does that mean for the rate of reaction?
That is faster.
It's faster. Okay, cool. And then what about temperature? Did we notice anything that was kind of off? Or did we see a trend or think there was a trend happening there? John, how about you?
The harder it was, obviously, it was pretty faster.
Mm-hmm.
And then room temperature was kind of like the middle one, and then the colder was a little bit faster than the room temperature. So it
Does that seem off to us? Because you said the hotter it was, the faster the reaction was. But then what happened with the room temperature here and here as well?
It was kind of longer rather than when it's colder.
So do we feel like that matches up with the trend, or it's like a discrepancy, it doesn't fit?
It kind of doesn't fit.
Okay, cool. So plot the data as you see it, but make sure to mention that.
Okay.
If you are, does anyone finish graphing the data right now? Cool. So, have you finished the conclusion section as well?
Yeah.
Awesome. As soon as you are at that point, there is one more thing I need from y'all really quick, if you look up at the TV. So, somewhere on your paper, literally wherever you have room, I want you to try and connect this to wildfires right now. How do you think increasing temperatures and increasing concentration of burnable plant matter due to droughts affects the rate of wildfires? Take a look at the graphs you have, at the data you've collected. Answer this question somewhere one more time. How do you think increasing temperatures and increasing concentration of burnable plant matter due to droughts affects the rate of wildfires in and around our community? So which one are you doing right now? You're doing temperature?
Yeah.
So if we look at the temperature.
Well, no, I put mine straight up.
Okay, I see. I see. And then are we just finishing for 25 and 75 then?
Well, they said they didn't do it, so.
But I would like for you to plot all the data, okay?
Oh, okay.
So for each graph, we need 3 data points for the 3 different trials that we had. So do you want to take a minute to do your 25 and 75 as well? Thank you.
Right here. Like the more CO2 in the air makes fires bigger and faster than ever.
So we think, sorry, what I'm hearing from you, exactly what you said. I think this is a pretty awesome statement. So more CO2, is that related to concentration?
Yeah, carbon.
Okay. And then heat in the air, you said, is
Temperature.
related to temperature. You think that's making the fires bigger and faster than they were before?
Yes.
Cool. And what makes you say that if you were to look back like at your
Well,
data right now?
I mean, like the room temperature is kind of like threw it off, but if you look at this one,
Mm-hmm.
like everything, like the reactions are like way faster. Like, yeah, it went from all the
As
way,
we see concentration increasing, what's happening to the time?
it's like a way faster.
It's going way faster, so the time's going down?
Uh-huh.
Okay, cool. And then I heard you mention something right here. You said the room temperature was sort of weird.
Yeah.
So what's the trend that you think should exist here?
It should be just like a linear line down.
It should be a linear line. So
Yeah.
like as temperature increases, what's happening to time?
Yeah, it should be going down.
It should be going down. But we see that there's something wrong here.
Discrepancy, yeah.
Discrepancy. It doesn't quite seem right. Cool.
Mhm.
Okay, thank you. In the next minute or so, let's see if we can get those graphs totally plotted, that conclusion section done, and the wildfire connection answered somewhere on your paper. Can I get a thumbs up if you've done all of that? If you're still working, keep working. Can I just get a thumbs up if you have done everything I've asked? Plotted, conclusions, wildfire connection. Okay, so we definitely need another minute or so. Let's take the time to do that. If you haven't already, please answer that question out, your wildfire connection. How does increasing temperatures and concentration of burnable materials affect wildfires in our community? Okay, we're gonna do a quick stand up, hand up, pair up. Just go ahead, stand up from your lab stations. Find someone else who is not in your lab stations. It can be someone from your old one. And just talk about this question right here, this wildfire connection. What was the conclusion you came away with?
Makes the fires go faster and spread quickly. I saw this in my observation when the temperature was hotter because it was hot and the time was faster than when it was cold and room temperature.
So, sorry, really quick. You said you saw that as the temperature went up, it took less time to fill the balloon. That's correct. And so, if it's getting hotter out here, what does that mean for wildfires?
The reaction is faster.
So, do we think fires happen more often or less often now?
Likely more often.
More often. Okay,
Yeah.
thank you.
I thought it affects the weight because it comes with
What did you think?
The increase of temperature and concentration affect the wildfire by making them like spread quicker.
Okay. And what makes you say that?
Because in the data, when the temperature got very hot, it took less time for a reaction to occur.
Okay, cool. Thank you so much. Hey, great work today, y'all. Go ahead. If there's anything you have left to clean up the lab, please do that. Otherwise, go push in your desk, and then I'll stand right now.